Okay, so we are going to continue on with the chapter 8. In 8.1 we talked about parabolas, and we said that parabola, we would have a vertex with a focus. So this is be your vertex. And then you would have a directrix. Okay, and if you remember correctly, this was P apart and this was P apart. And the equation looked like this. Okay? So that is what we did on the parabolas. Today we're going to talk about the circles and ellipses. So this is kind of a new thing for you guys, although you talked briefly about what an ellipse looks like before. So an ellipse is going to look like this, where you have the vertex, two vertexes. So this is a vertex, this guy's a vertex, and then you have two focus, otherwise known as foci. So this will be a focus, this guy would be a focus. Okay? So, the definition of an ellipse is that if I add these two together, they would always stay the same. From this point, the distance from here and the distance to here, when you add them together, they are always the same. Okay? So that is the definition. So if I go all the way down to here, the distance between that and you add that is the same as this distance plus this distance, which is the same as this distance to here, from here to here, added together. Okay? And I'm not going to do the actual proof like I did with the parabola, but if you do the math, let's say that the focus is C and COA, and the vertex is A. These would be negative numbers here, right? From here to here would be A, here to here is A, here to here is C, and this here to here is C. Okay? And we will call this B and negative B here. Okay, some new nomenclature here. So A is called the semi-major. B is called the semi-minor. Okay? So this length is a semi-major. This is a semi-minor. Okay? As you can see, if I take this and put it over here, right here, okay, then I have a triangle that looks like this, where I have C and B. So this guy here, which just happens to be A, is going to be, so A squared is equal to B squared plus C squared. And the actual ellipse equation looks like this. Looks like that. Okay? A squared, x squared over A squared plus y squared over B squared is equal to 1. Okay? So you're probably looking at this thinking to yourself, well, this looks awfully familiar. This looks almost like a circle. In other words, if I had something that looked like that, then I can multiply both sides by a squared. Now we get x squared plus y squared is equal to a squared, which just happens to be an equation for the circle. Okay? So for you to think that that looks pretty close to something is correct. Okay? As a matter of fact, it turns out, well, that as you can see, a circle is a special ellipse. It is an ellipse when A is equal to B, okay, when they're the same, okay? In other words, I go from here, and I'm scrunching it in, the vertexes are getting closer and closer to the foci, and it becomes a circle, okay? So that's how the ellipse works. So, what do we need to talk about? We have the, okay? So we have an ellipse that looks like this, where it's on the axis, the x-axis, the focus and the vertex are on the x-axis. Obviously, we can also have a ellipse that looks like this, where it's going this way now, okay? So what do I have here? I would have the focuses here, or the foci, so it would be C and negative C. Then I have the vertex here at A, negative A. This is the semi-major now. The semi-minor would be B and minus B. Okay? If you look at it, this one is notated as this. And again, wait a minute. Okay? So, A squared is equal to B squared plus C squared again here, right? Because if I put it from here to here, this length is the same as a semi-major. This length, semi-major. This length, semi-major. Okay? All right. So this looks awfully close to each other. Okay? So isn't this nothing more than just flipping this around? And then I get that? Well, the answer is no. Because if you look at here, there is no way that B is larger than A. A has to be larger. In other words, and the same thing over here. A has to be bigger than B. Okay? In other words, the larger number on the bottom comes first here. So the one that has the larger number underneath it dictates whether the ellipse looks like this or whether it looks like this. Okay? So that's one thing you need to pay close attention to when you're looking at the ellipse. Okay? Obviously, like the parabola, now we can go ahead and we can translate everything around, right? We can take the center here, we can translate that around, okay? So if I took the center and I moved it, let's say H and K, it would be like that. We would move it around like that. Okay, so that would be a translated ellipse. Okay? So that looks good. So let's go ahead and see if we can do some of the examples here. Let's do example number 1. Okay. Example number 1 says, it's on page 583. Example number 1 says, find the vertices and the foci of the ellipse 4x squared plus 9y squared. 4x squared plus 9y squared is equal to 36. Okay? So first of all, we need to change this into something that looks like this. Because it's the standard form of ellipse. So obviously we want to divide everything by 36 to get the 1 on the right-hand side. So if I divide everything by 36, I get 4x squared, 36. 9y squared, 36 is now equal to 1. And this becomes 9. 4 and 36, so I get 9. 9 and 36, I get 4. Okay. Further, this becomes 3 squared. This becomes 2 squared. Okay? So, first of all, since this guy is the larger number, this has to be an ellipse that looks like this. It looks like this, with a semi-major here and a semi-minor here. So in other words, it's going to look like -3 and 3. Let's go over here. And 2 and -2. Here. It's going to look like that. Okay? So what we need is, the only other thing that we really need to find here is the foci. Okay, the foci is the C, right? And then the Pythagorean theorem here, or the Pythagorean relationship here, is that a squared is equal to b squared plus c squared, where I know that a is 3 and b is 2. So I get 9 is equal to 4 plus c squared. C is going to be c squared is equal to 5, which means that c is root 5. I mean, in other words, I have root 5 here and -√5 there. So the question they asked for the vertices. So these are the vertex. Vertices are here and here. And then I have the foci, which is here and here, like that. And that's it. That's all they're looking for. Okay? So you see how I went from here, determine, first of all, whether it's an ellipse that goes this way or that way, and that is determined by which one has the larger number underneath it. This has a large number underneath it, so it's going to have everything on the x-axis. So I have the foci on the x-axis and the vertices on the x-axis. Okay? And then I did this to use this equation to find the foci. Okay? So that was example number 1. So this would be one where the center was at the origin. Now let's see if no, not this one. I guess it's the next one. Let's do example number 2 first. Okay, on example number 2. So it's find an equation of the ellipse with the foci of that, and minor axis has a length of 4. Okay, so let's see if we can find that. So, foci are 0 plus or minus 3. And then I have the minor axis being 4, which means really that the semi-minor is 2. It's half of that, right? So, and we're going to sketch that. So I have the foci are 0 plus or minus 3. So it's going to look like this. So I have 3, I have -3, and then I have the 2 and this is the semi-major, this is the major, this is the semi-minor, which is 2, which makes the minor 4 altogether. Okay, so it's going to look like that. Okay, so in this one, I have the y, everything's on the y-axis, so I'm going to have the larger number here, and it's going to be 3, so I get plus x squared over 2. 2 squared is equal to 1. Okay, so we're good there. Oh, wait a minute. Okay, so this is B, this is C, so I have to find what A is. So that's not correct. So my B, this is A. Oh, huh. So this is the foci. So in other words, I have 3 is the foci, not the vertex. I solved for something that looked at had that. So the foci are 3 and -3, 3 and -3. So the vertex would be over here. I had -2 and 2. So it'll look like that. So the vertex is here. So basically I have C is equal to 3, B is equal to 2. Here and here. So I need to find out what A is, because then A is going to give me what goes underneath here. So I have A squared is equal to B squared plus C squared. So I get 9 plus 4. So A is going to be equal to root 13, which means that the 13 squared goes over here. So 13 root squared plus over here was the 2 squared. The actual equation is going to be y squared over 13 plus x squared over 4 is equal to 1. That would be your answer. Okay? Okay, so now we're going to do just as we did with the parabolas. I can translate this around, and I kind of briefly showed you if I had h and k, how I would do that. So let's see if we can go ahead and use that now and actually solve a couple problems here. So example number 3. Example number 3, finding an equation of an ellipse. Find the standard form of the ellipse that has the end points, the major axis has the end points of -2, -1, 8, and -1, and minor axis has a length of 8. So I have the end points are -2, -1, and 8 and -1. So here we go. -2 and -1. -1. I'm going to go over here. I'm going to have 8 and -1. Those are my endpoints. Okay, so that's -1 right here, right? Because I have -1 here and -1 here. And I have a minor axis of a length of 8. So I'm going to go in between here. So I have to be right in the middle here, the center here. So I have -2 and 8, so that's 10, which means here to here is 5, which means this here is 3, okay? But it says that my minor axis has a length of 8, which means I go 4 up from here. So I'm going to be here, which means this is going to be 3 and 3. I had -1, I go up 4 to go 3. -1, I go down 4 to get 3 and -5. So this is one that looks like this here. Okay. So if this was in the center, I would have had, I'm on the x-axis here, so I'm going to have x squared plus y squared. And what is my a? My a is from here to here was 5. That would be 5 squared. This was 4 squared. 16 is equal to 1. So this would be if my center was in the origin. Now my center is not in the origin. My center is my center is here. So I have to make that translation here. So I'm going to get x minus 3 squared over 25 because I moved it 3 to the right and then 1 down. So 1 down would look like that. So that there would be my answer. Okay? Let's do one more. Example number 4. Example number 4. Okay. Let's go ahead and briefly review before we go. Semi-major was 5. The major is 10. Semi-minor was 4. The minor itself was 8. So here you go, I got this. This is my vertex. If I asked you to find the foci would be over here and here. So I have to go C this way, which I don't know what C is. A squared is equal to B squared plus C squared. A squared is here, 25. B squared is 16. C would be 3. So I have to go 3 from here to here. So it would be, what? 6 and negative 1 on this side. Over here, it would be 0 and negative 1. Because this distance here would be 3, this distance here would be 3. Okay? Okay, so that's that. Let's move on. That was example. Okay, now let's see if we can do example number 4. Example number 4, 5. Okay, now this one they're going to give you the equation x plus 2 squared over 9 plus y minus 5 squared over 49 is equal to 1. So, and they want you to find the center, vertices, and foci. Okay? So they're trying to trick you up here because this is going to be 3 squared, and this is going to be 7 squared. So in other words, this guy is larger, so you're going to have a situation where you have an ellipse that looks like this now. Okay? So it looks like this with 7, correct? So your A is 7. So I'm going to be... Okay, where's my center here? Let's talk about the center. The center would be, normally would be 0, 0, but I have these corrections here. So my center is going to be at negative 2 and 5. If I start from 0, 0, I move 2 to the left, and then 5 up. So that's where my center is. So let's go ahead and start drawing that. My center is at negative 2 and 5. Negative 2 and 5, that's my center. And then I'm going to go 7 up here. I'm going to go from 5 up 7. So negative 2 and 12. I can go 7 down. From 5, I go 7 down, so I'm going to have negative 2 and negative 2. Then I'm going to go this way, 3 each, right? So I'm going to go from negative 2 over here, so it's going to be over here, negative, so it's going to be 1 and 5. I'm going to go 3 over on this side, negative 5 and 5. That's what my ellipse looks like. And what do I need to find? They wanted me to find the vertices. So the vertices are right here. So the vertices, negative 2 and 12, negative 2 and negative 2. I already found the center up there. And then I need the foci. So my foci is going to be right here and here somewhere. So I need to find what the C is. So I have A is equal to 7, B is equal to 3. So I have A squared is equal to B squared plus C squared. 7 squared, 3 squared plus C squared, 49. 9. 40 is equal to C squared. So C is going to be equal to the root 40. And this is the root 4 times the root 10. 2 root 10. So C is 2 root 10. So I'm going to have to go up 2 root 10 and down 2 root 10 from here. So I'm going to stay at negative 2. 5 plus 2 root 10 is 1. Negative 2, 5 minus 2 root 10 will be down here. Okay? All right. So that's that. We're good with that. It's example number 4. Okay? So, in the ellipse, something that you did not have in the parabola, that you do now have in the ellipse, and we will find out next lecture in the hyperbola also, is something called the eccentricity. Eccentricity, okay, so let's go if we had x squared over a squared, y squared over b squared is equal to 1. Okay. The eccentricity is measured as this, c over a. If you remember correctly, c was from here, if you move the c, this guy over, I get a squared minus b squared is c squared, so I get a squared plus, not plus, negative b squared root over a, which can also be written as a squared minus b squared over a squared, 1 minus b squared over a squared. So these are all the same expressions for the eccentricity. Eccentricity basically means, is the ellipse really flat or is it more closer to a circle? Okay, so if it was closer to a circle, that means that c would be really small. In other words, a squared and b squared would be fairly close to each other, making it closer to a circle. So if c gets really, really small, this guy becomes closer to 0, okay? So it can be closer to 0, okay? If c became really large, what's happening there? If c became really large, that means that b is getting closer to 0, okay? If b gets closer to 0, this gets closer to 0, which means that e would try to get close to 1. So as you can see, the eccentricity is a number that's between 0 and 1. The closer to 0 means that you are closer to looking like almost like a circle. If you're closer to 1, you're closer to looking like a pancake, like that. Okay? So that's that, and so let's see what the eccentricity means. Okay? I will leave you with example number 5, and you guys can figure that out. It should be pretty simple. And then on example number 6, there is a thing called a lithotripter, and that's actually pretty a cool thing. It is how to use the ellipse or an elliptical shape to deliver a beam, a radiation beam, to a vital organ or some organ without damaging the other organs next to it. Okay, so that's pretty interesting. So you can take a look at that, and we'll call it good.